Hello everyone, I welcome you all to this channel on Mac Talk. Today we are going to see what is a static and dynamic fluid. So we'll be looking the difference between static and dynamic fluid. So the very first thing that you need to understand is what is a static fluid. See, we generally understand static fluid by considering it as a rest fluid. Okay, we say wherever there is a rest fluid, that is known as static fluid. But that is not the case, because in this fluid mechanics, whenever we are saying a static fluid, we mean that the particles that are present in the fluid must not move relative to each other. So if there is a fluid that I have and that too is moving, then also I can call it static fluid. How? If there is no movement taking place in between molecules with respect to each other. If there is this A molecule and this B molecule is moving together all throughout the movement, all throughout the flow, then I will call it as a static fluid. Or you can say, if there are layers of fluid that are moving with the same velocities without any relative motion to each other, then it will be known as static fluid. Now the another fluid we have here is dynamic fluid. In this fluid, the fluid must be moving, but this time the movement of layer will be such that they will be moving relative to each other. This means the velocity of the top layer could vary, or it will be differ than the other layer of the fluid. So in this way it is understood that the velocity of all the layer present in a static fluid will be same, but in this dynamic fluid the velocity will differ. Now the second thing is, in a static fluid there is no any shear force which act on a fluid, and even if there is a shear force, the fluid immediately do not resist it and immediately move, like as I said earlier, that the static fluid will move in such a way so that the particles that are there will not move relative to each other. So when there is this shear force which is applied to static fluid, there is no resistance created against it as a shear stress. So in this way we can understand that the shear force will not have any resistance as shear stress in static fluid. But in dynamic fluid, when we apply shear force, there is some resistance that takes place because of the viscous force which comes into picture whenever there is a motion. The third point is, in static fluid there is only normal stress that exists because there is some weight of this static fluid, and due to that there is some opposite force which is the normal force, and due to this normal force there is the normal stress that comes into picture. But in dynamic fluid there is weight also, along with that there is some shear force which is causing shear stress to develop, and this shear stress is present in dynamic fluid. So in this way, in static fluid there is only normal stress, and in dynamic fluid we have shear and normal stress both. The fourth point is, when it comes to linear deformation means the elongation of a fluid element in a particular coordinate. In a particular, suppose this is the x and the fluid moves in such a way that it adds dx to it in x coordinate and dy in y coordinate. So this is the linear deformation. So the linear deformation in static fluid is more and is large. Why? Because there is no any viscous force that comes into play when there is shear force is applied on a body, or when the fluid is moving, because the layer that are there are not moving relative to each other. That means there is zero viscosity, or you can say viscosity does not exist. And in dynamic fluid, because of the viscosity, there is this viscous force which act against the shear force. So in this way the deformation will be lesser in case of dynamic fluid. Now, summarizing all that, we can say there is no resistance to shear force in static fluid, because when you apply the shear force, it immediately moves. Well, either it immediately moves, or there is no such application of shear force, or the static fluid could remain in rest without even applying any shear force on it. But in dynamic fluid, we have to apply shear force, and that shear force is resisted by this viscosity. So viscous force resists the shear force. The second point is, all layer of fluid are either still or moving at same velocity, as I've said earlier. And in this dynamic fluid layers are moving relative to each other. Third point, linear deformation is large, and here linear deformation is small. And the fourth point, only normal stress exists, and here both normal and shear stress exists. Thanks for watching this video.